Okay, so here's case 2 of solving log equations. Most of the time with log equations, you will not have a log on both sides. You will only have a single log, as you can see in this first example here. So we can't use the strategy that we were just using. We're going to use a similar strategy that we used when we were solving our exponential equations. Okay, you've got to focus on where the variable is. So in this first example, the variable r is inside the logarithm. Now notice there are no parentheses in this example, so that means that this is the only thing that is inside the log. Contrast it with example B here, where there are parentheses, so that -2 is a part of that logarithm in B. -7 is not a part of the logarithm in part A. So we're trying to get the variable by itself. It's stuck inside the logarithm. We must begin by getting the log by itself. So in this case, we need to add the 7 to the other side. Now, again, there were no parentheses to begin with. I'm going to put the parentheses there just to be clear and explicit as to what's inside the logarithm, because it's kind of protected in there. You can't take it out without changing forms. -6 plus 7 is 1. Now, the log is by itself, the variable is stuck inside. The only way to get it out is to change forms. So just like we did the other day when we were in exponential and the variable was stuck in the exponent, we had to change it to log form to get it out. Now we're in log form, we've got to change to exponential to get that variable out. So we can use our swoop. So we have 8 to the first is equal to 8r. And then we can solve for our variable by whatever means is necessary. And 8 divided by 8 is, of course, 1. And we should still always check our solutions, remembering change of base. So we've got the log of 8 times 1, okay, divided by the log of 8 minus 7 does give us -6. So 1 is the correct answer here. Okay, similar scenario here with b. We've got 4 log of -9b minus 2 equals 16. But again, this time the -2 is inside that log, so we can't mess with that. The problem here is that there is a multiple of 4 in front of the log, so we start by getting rid of that by dividing both sides of the equation by 4. Now our log is isolated. There's nothing else outside of the log. Everything dealing with the log is inside the log, so we change forms. This time there was no base, so remember that is base 10. It's understood to be base 10 when there's no base. So 10 to the 4th is equal to 9b minus 2. So our number is going to get a little big here. We're going to add 2 to that 10 to the 4th. 10 to the 4th would be 10,000. So that would be 10,002. When we add 2 to it, that's equal to -9b. Divide both sides by -9. Don't know whether this is going to simplify or not. Let me just check really quick. My 10 to the 4th, adding 2, divided by -9. I know it's not evenly divisible, so I'm going to change it to a fraction. -3,334 divided by 3 is our v. I would mostly store that as x. Definitely storing that as x so that I can check it for log -9x minus 2. So seems like a very, very strange answer, but it works out in our problem. That is the correct answer for our variable. Okay, let's look at one with a natural log. Okay, now, please, please, please be careful with this. It's very tempting to want to add that -8 plus 6, but remember that that 6 is being multiplied by the natural log. So it's almost like that's -8 plus 6x. You know you can't put those terms together. So don't try and put those together right there. Okay, we need to start by adding the 8. and then dividing by 6. Okay, now the natural log is by itself, so we need to change forms. This has a base of e, so that's e to the first is equal to 2m minus 1. Now, whenever e's are involved, we are not going to consult our calculator.
Students that are writing bus 1, report to that bus at this time. Students writing bus 1, report to the bus at this time.
Okay, we are not going to go to our calculator here. We are just going to keep our work flowing because there is no way e is an irrational number, meaning it is not a terminating decimal, meaning it cannot be expressed as a fraction. So we are going to leave it as is. Now, there are actually 2 options for your e on the calculator. It's either here with the natural log, but that automatically has an exponent. In this case, our e doesn't have an exponent, so we're actually going to use second division, and that's going to give us just e plus 1. Now, because I forgot to put my parentheses in there, I need to press enter after my numerator and then divide by 2, store as x, and then I can go back in and check my solution. And it does give me -2, so e plus 1 divided by 2 is the correct answer. And we want to leave that in exact form. We don't really need a decimal version of that. Okay, one more example. Let's do a log base 5. Again, similar to the previous example, you do not simplify the 9 minus 2 because that is 2 times the log. So we need to start by subtracting the 9 from both sides. That gives us -8. Then we can divide by -2. And that gives us 4. Now our log is isolated. There's nothing else outside of the log. So we need to change forms. 5 to the 4th is equal to -b minus 9. I'm going to add 9 to 5 to the 4th. That's 634 is equal to -b. So that means -634 is equal to +b. Let's check that. 9 minus 2 log of -v, and v is -634. So those negatives negate one another.
Those students writing bus 1 needs to report to the bus at this time. Bus 1 students report to that bus at this time.
Okay, so look at how I put this in the calculator. Fortunately, there's not really any extra parentheses that are necessary. The calculator follows the order of operations, so we're good to go there. Okay, so you need to complete the remainder of your worksheet, 28 through 40. They are all problems of case 2's sort.